Welcome everyone. Today we're going to do this wonderful car. We'll have this cube, grabbing which will enter our car, and again we can grab it again and exit the car. So let's actually get into the car. And as we can see here, we have our handle and we have a wheel. So basically, if we put our handle towards, our car will accelerate. Once we release it, our car will stop and handle will return back to its initial position. Once we put handle back, the car will go back and it will also stop. Also, we have our wheel right here. So we can actually control the way our car moves. So let's actually turn left. We can go left. We can turn right. And we can stop, for instance, get out the vehicle, see how everything looks beautiful, like that. And basically, yeah, today we're gonna make this beautiful car. So first thing we gotta do is we're going to work on our objects and we're going to rig the car and export some meshes. So I will go ahead and go to Blender. So this is basically a prototype of a car. It's not actual car downloaded. I just made it in like 10 minutes just to illustrate you how rigging and how exporting works. So the first thing we need to make sure is that our car is facing positive X direction. So make sure that the front of your car is pointing this direction, positive X, this direction right here. And afterwards, you will want to have your wheel separately, right? So you are riding a car and you want your wheel to rotate. You don't want to put any extra mesh on the wheel. So what you'll have to do, you'll have to slice your mesh, or you need to have your steering wheel separately. So for this purpose, I already have it separately right here, and I'm going to export it separately from the car. So I'm going to select it, Control S, selection to cursor. And as you can see here, my steering wheel has snapped to the origin. And afterwards, having our steering wheel selected, we're going to our file, export, FBX. I'm going to save on my desktop, and I'm going to call it wheel tutorial. And afterwards, I will go ahead to my path mode. I'll select copy because maybe you have some textures on the wheel. Therefore, you need to select copy to bring those textures in Unreal Engine. And make sure you'll tick this icon. Afterwards, we want to limit our selection to selected objects, and we want to export only armature, mesh, and other. Afterwards, since we have decided our mesh is facing positive X direction and its up vector is Z, we'll go ahead and select forward to X forward and up to Z up. Afterwards, we're going to geometry and make sure that instead of normals only, you will select faces. Afterwards, you will go to your armature, you will deselect add leaf bones and bake armature. And afterwards, we can select this to our location. So in my case, it's desktop. Perfect. Afterwards, we need to start rigging. So for rigging, you need to make sure that you have 5 different objects in your scene. Car body, front right wheel, front left wheel, rear left wheel, and rear right wheel. Those 5 objects. So in my case, I will just make them like this. So this is basically my car. So afterwards, we need to rig our car. But don't worry, there is a special plugin that already does it. I will leave the link in the description, make sure you download it. But I'll just go ahead and share this with you. So once you're in this website, you will go ahead and download it here. And here you'll see the zip folder. So I will go ahead and download it. After you've downloaded your zip folder, you can go back to your Blender, click Edit, Preferences, and here you will see the tab called Add-ons. So in here, you will press Install and look for the zip folder you have downloaded. This is UE5 vehicle rigging. So you double click on it and it will be added to your Blender. Then click refresh, and here you will type vehicle and you will see generic Unreal Engine 4 vehicle rigger. Make sure you enable it. And afterwards you will see that it appeared in your UE4 vehicle. So afterwards, you will see that you have vehicle base, front right, front left, rear left. So vehicle base will be our base. So I will select the base. Afterwards, front right wheel, it's this one, rear right, this one, front left, this one, rear left, this one. And after we have selected this, we can see that our rig vehicle is unavailable. So what you'll have to do is that we'll have to set our unit scale. So I will click on here. Now this is available, so we can press rig vehicle. And make sure you adjust your bone lengths because sometimes it might be too big, so I adjusted it to minus 0.009 meters. And as you can see here, our vehicle is now rigged. So we have, for each wheel, we have a bone, and for our body, we also have a bone. So afterwards, we need to set the scale for our vehicle back, because now if you click on your vehicle, I'll show you in object mode, you will see here that the actual size of your vehicle is 0.02 meters. That's not something we want. So here I will go to scene tab, it's this one, and unit scale I'll change back to 1. And now, by pressing our vehicle, we can see the dimensions have gone back. And make sure, by the way, that your dimensions are right for your vehicle, because sometimes the vehicle might be scaled down or scaled up. So make sure you have the right dimensions. And afterwards, we first select the bones, then we select the body of our vehicle, as well as our wheels. We go to File, Export, FBX. And here we're applying totally same settings. So I will code car tutorial. And you can go ahead and save it. So once you're in Unreal Engine, you're going to just drag those meshes into your game. So now I will go ahead and I'll drag the wheel I have saved. I have a different one, just for the sake of tutorial. Like this. So now I have a wheel. And I made specifically 2 colors for the wheel. So this is the region we're going to grab our wheel. Afterwards, we're going to do the car. But for the sake of this tutorial, what I'm going to do, I'm going to use the VR expansion plugin. So I will go to VR expansion plugin and I will drag this car from here. So I will go ahead, it's called Sedan, and I will look for the Sedan here, skeletal mesh, right click, asset action, migrate. And I will save selected and I'll hit OK. Afterwards, I will go to my project. So it's my car tutorial and I will save it to content folder like this and wait until it exports. So once it has been exported, I will come back here and I can see that in VR expansion plugin, I have Sedan. And you will have something similar. You will have physics asset, skeleton, and skeletal mesh. So if you don't have physics asset, right click on skeletal mesh, create, physics asset, create. But I want to create a physics asset from scratch. So I will delete this physics asset. In case you have taken the same car, you can go ahead with the physics asset it is right now, but I will delete it for the people who don't have it. So I will right click on skeletal mesh, create, physics asset, create. I will choose default settings here, create asset. And here we have our car. So as you can see now, if you choose the wheel, I will open the bones. So show bones. It looks really bad. The collision is like really high. So what we are going to do? We're going to delete everything. I'll just delete all the collisions we have here just to show you. And in our vehicles, I'll select them. I will add a sphere collision. So it must be like that and add bodies. And as you can see here, we have added collision for our wheels. Afterwards, we need to make a precise collision for our body. So I will select vehicle base. And in here, my primitive type will be single convex hull. And I'll click add bodies. And as you can see here, our precise collision has been added to our car body. And I'll click save and close the menu. So if you put your car right now here, you will see that it is perfectly on the ground. I will go ahead and create a new level because I want like a big space here. So I'll select basic and I'll save this level like this. And since we are playing in VR Pawn, make sure that your player start is 45 units down like this. And now what we have to do, we have to install a plugin. So we'll go to our edit plugins and in here look for Chaos Vehicle plugin. Enable it, click yes, and restart your engine. So once you're in your engine, I'll come back to my new map. We'll go ahead and create a special blueprint for our car. So I will right click, blueprint class, and here we're expanding all classes. And look for vehicle, wheeled vehicle pawn. Select this one, and let's call it BP vehicle. And let's open it. And we can see here that we have our vehicle mesh and vehicle moment component. So vehicle moment component is basically settings for your car, like center of mass, acceleration, speed, all different settings. And you can play with them, but I'll do everything for default right now because there's literally a lot of things to do here. So I will go to my mesh and I will select our car mesh. So our Sedan skeletal mesh. And as you can see here, our car has appeared. Afterwards, we need to map our wheels to this car. So let's select our vehicle movement component. And as you can see here in our wheel setup, we have wheel setups. So we'll click 4 times since we have 4 wheels. If you have more wheels, add all of them. So I will have them like this. And in bone name, we need to have specific bone name as in our skeletal mesh. So let's go ahead and open it. So make sure, so in here, you need to have a specific order. So your first 2 wheels should be your front wheels. So first bone name is going to be my front left. So I will copy selected bone names and I'll paste it here. The same I'm going to do with the front right. Like this. Then rear left. And our rear right. Like this. Afterwards, we can compile and save. So our next step here will be actually creating another blueprint. So we can right click blueprint class and we'll look for vehicle wheel. So chaos vehicle wheel, and we'll select it. Afterwards, I'll call it BP front wheel, like this. So we'll open it. And here, make sure that your axle type is set to front, and our front wheels are affected by engine, like this, and they are affected by steering. So in front wheel, you will adjust your wheel radius, but don't do it right now. You will see how it looks in the game, and we can hit compile and save. Let's duplicate this BP front wheel. I'll call it BP rear wheels. So BP rear wheel, like this. I'll open, and now rear wheels are affected by handbrake. So make sure you'll select this one here. And make sure your axle type now is rear. And in here, make sure you will deselect affected by steering, like this. Let's come back to our BP vehicle, and in here, in our vehicle movement component, you can see that our wheel class is set to chaos vehicle wheel. So now, since we have created blueprints, let's assign our front wheel to front wheels, and rear wheel to rear wheels. Okay, perfect. Afterwards, let's go to our mesh and assign a physics asset. So look for physics asset override, and select seed in here, or your physics asset you've just created. So afterwards, we need to simulate physics of this mesh. So you will go ahead, look for simulate physics, and make sure it's on, like this. So hit compile and save. If you go to your level and actually put a car in the level, like this, and simulate the game, you will see that your car has a suspension now. And you can actually show it or even like move it forward and it will slide. So now if you see that your wheels are not touching the ground, what you are going to do, you will go to your front wheel and you will adjust your wheel radius and try to adjust it so that the wheel touch the ground. And you can actually show it or even like move it forward and it will slide. But something is wrong here. We can, oh, holy crap, I threw it away. So something is wrong here. We can see that our wheels are not rotating when our car is actually moving forward. And when our car is actually simulating suspension, you can see that the whole car does it, but not the wheels. So to do this, we'll have to create animation blueprint. So let's go ahead, look for our skeletal mesh, right click, create animation blueprint. And let's code app vehicle. So here, the first step we have to do is that we need to select our class settings, and our parent class should be set to our vehicle animation instance. Hit compile and save. Afterwards, we have to add specific node called wheel controller for wheeled vehicle. And we have to connect the output from here to here. Like this. We have to create another node. It's called mesh space ref pose and connect it to component pose. Hit compile and save. Now we have to assign this animation blueprint. So let's go back to our vehicle blueprint. And in our mesh, we'll select our newly created animation blueprint, ABP vehicle. Hit compile and save. Now, if I go to the game, I put my vehicle in the level, you will see that my wheels are actually simulating suspension. And if I move my vehicle forward, like that, you will see that the wheels are actually moving towards the car, like that. So now if you see that your wheels are not touching the ground, or your wheels are not rotating and you think it's bug, what you are going to do, you will go to your front wheel and you will adjust your wheel radius. And try to adjust it so that the wheel touch the ground, because sometimes the plugin might not notice that the radius is good enough to actually perform the wheel animation. So please play with this value, and if something is not working, this should fix it. So now we have another problem. We need to make our vehicle move, and we want to adjust the speed our vehicle can go, can max out. So again, we'll go to our vehicle blueprint, to our vehicle movement component, and in here, we'll scroll down to our engine settings. So here, mechanical setup, engine setup. And here we have our torque curve. So to change your torque, that's basically how fast your car will speed up, you can double click on here and you will see this system. So basically on the x-axis is time, so we can go ahead, add a key node and put the first one on 0 and 0. So I will just go ahead, create another node. I will put time 1030 and value will be 670, like this. So this is basically the acceleration over time. Afterwards, after this point, I want acceleration to be slower, so I'll add another key node, and I will have time 2700, and maybe the value is 690, like steep acceleration. Then I will have another node, I'll put it to 4400, and the value will be around 380. Then another node, like 5000, and I'll put it to 0, like this. So basically this graph represents car torque, and now we can close it. So as you can see here, if we put those two buttons, we have graph something like that. So now I will explain you how everything works. So basically our vehicle movement component has a couple of functions. The first one we want to look at is set throttle input. this function accepts value from 0 to 1. So if we have 1, it means our car will speed up on the maximum speed. So let me look for my car. And let's see. So as you can see now, car actually speeds up. So now let's actually test something new. We'll have our car accelerating for instance, 2 seconds. Then it will brake, and then we will start going back. So for this case, what do you have to do? We have to set throttle input to 1. We have to make a delay. So for the first 2 seconds, it accelerates. And in order for us to go actually back, the only thing you can do now is actually brake. So if we apply our set brake input to 1, what is going to happen is that our throttle input and brake input will just cancel out each other. So the car will actually stop. I can illustrate you. So now if you launch this, car will accelerate, then decelerate, and it will stop. It will not go back. But for the car to go back now, we'll have to set throttle input to 0. So like this, to 0. And then we can make our brake input. So as you can see now, car will accelerate, brake, and decelerate backwards, like this. So yeah, now we know how the car works. Let's actually go ahead and implement the logic. So what I've decided to do is that I want to have some kind of button or maybe some kind of point that we can grab and we'll go inside the car, and the same point will grab and go outside the car. So let's actually add a cube. So I will add a cube here, and I will make it maybe red. Let's select a different material. So maybe pink one. So I will scale this down. I will scale this down more, and I will put it somewhere on the door. So once I touch this, I want to get into the car, but we don't know where exactly we want to go. Therefore, I want to create a specific scene component that will be actually responsible for telling me where do I want to put the camera. So I will go ahead, I will add a grab component because we want to be able to grab this cube, and make sure that your grab component, grab type, is set to custom. Make sure it does, because otherwise you will grab the cube instead of getting into the car. And now, just for me not to forget, let's go ahead and edit our grab component a little bit. Just because we need to keep track of our motion controller in our car, because we are actually steering our wheel and we're having our lever that actually controls the speed input, we want to keep track of our motion controller to make the lever pointing towards it. So I will go to my try grab, and here we'll see our onGrabbed. So onGrabbed, I want to add another input, and I want to add our motion controller. So motion controller, and it's going to be of type motion controller component. Hit compile and save. And now all you have to do is just to connect this motion controller reference to here. Like this. Now we can come back to our car, and as I was talking before about the reference point, that's what we are going to do. So I'm going to add a scene component, and I will call it head position. And I'll put the scene component around here. So I want my head to be somewhere on this spot, or maybe like lower a little bit. Like this. So after we have those variables, let's actually program it. So I will go to my event graph, and by clicking our grab component, we can see that we have our event onGrabbed. So let's actually get it. So now once we grab it, let me actually open VR pawn to explain you how it works precisely. In our VR pawn, we have our VR origin. So that's basically the point from where we start counting our real world height. So what we can do? We can, in here, in our car, we can get player pawn, we can cast to VR pawn, because we need to check if it's VR pawn we are playing on, and then we need to create a variable. And let's call this variable in car. So it will be of type boolean. And we need to check it, because if we are in a car, we need to make logic for getting out, and if we are outside the car, we need to make logic for getting in. So I will make a branch here. And first, let's consider when it's false. So we are not in a car, we are just getting in. So what I want to do? I want to count the difference between our head position and our camera in our VR pawn. And this difference I will apply to our VR origin. So basically I will put the VR origin downwards. So that's what I'm going to do. I'm going to get my head position. I'm going to get world location. And I'm going to do the same with our VR pawn's camera. So we are getting our camera, and we are also getting its world location. And we just subtract those values. So afterwards, we are getting our VR origin. That's the root component of our VR pawn, and we just add a world offset to this value, like this. And afterwards, we are in a car, therefore we set in car to true. And in order for our VR pawn to actually follow the movement of the car, like up, down, left, right, we'll have to get our VR origin again, like this, and we'll have to attach component to component. And our parent, in this case, will be our head position. And make sure that your location rule is set keep world, and everything else is also keep world. Okay, hit compile and save. And make sure it's on false. I don't know why I had it on true. Make sure this logic is in false bin. And afterwards, once we are in a car, we need a kind of point where we want to get out of the car. So I'll create another component. I can duplicate my head position, and I can make it the child of my head position right here, and I will call it exit position. And I will put this component somewhere here. So that will be basically the place where I exit the vehicle. It doesn't need to be specifically on the ground. It can be somewhere like here, and I can hit compile, come back to my graph. And here I will get my exit location, and I'll get world location. So now we want just to align the X and Y components of this location. Since we're not interested in Z, we'll just recalibrate our height. So I'll grab from my VR origin, set world location. I'll split the structure pin right here, connect X value and Y values to here. And it will be on true. Afterwards, once we are on this X and Y, our height is not calibrated because we have lowered our height when we were sitting in the vehicle. Therefore, we have to set tracking origin. It will recalibrate our height again. So set tracking origin to stage. Afterwards, we need to make sure we are not in a car. So false here. We are setting it to false. And finally, we get our VR origin and we detach from component. And make sure your detachment rules are keep world everywhere. Like this. So this is the code. You can compare. But what I'm going to do, I'm going to try it in the game. So I'll have my vehicle here. I will put it closer to my player, somewhere here. And since I've created a new level, I will also add a nav mesh bounds. So nav mesh, because I need to define an area I can teleport in. So I will make this area. I will press P to make sure it's all green. Yep. So now I can jump to the game and see if it actually works. Here's our car, and once we grab this purple cube, we are in the car and on the spot where we are supposed to be. So yeah, it actually works. And if we want to quit our vehicle, we can put the same cube and we are out of our vehicle. So that's perfect. And don't pay attention if I'm too low because I'm sitting, obviously. So you will be standing like this. So let's actually go ahead and continue with our code. So now we want to manage our speed by having a lever and actually pulling it towards us and backwards. So what you're going to do is that you're going to access the Google Drive link I have left in the description, and you're going to download the level mesh. So what you're going to do, you're going to access your level and drag the joystick FBX file inside your level. And just hit import all. And as you will see here, you have your joystick imported. So we can set its material to something white, or maybe any color you want. I'll choose default material, a pink one. And now let's go to our vehicle. So I will go ahead and add my joystick. So static mesh, and it's going to be our handle. I'll call it like that. And I will choose my joystick. So now you can have the same location as I do right here. I will even scale it down like this. So here will be my joystick that will be responsible for speed. And now make sure that in its static mesh collision preset, you will set it to custom, and object type is physics body, because our grab component reacts only to our physics body. And now this joystick also has a collision. I've already made a collision for you. So if you go here and show the collision, you will see the collision is set to this upper part of the handle. That's where you will be able to grab it. So now back to our vehicle, we have to add a grab component underneath this handle. So I will add grab component. I will call it lever grab component like this. And also, guys, make sure that your grab components have the same location as your cube. For instance, here, I will set the same location for my grab component. It should be here on the cube. And on the lever, when you have your lever grab component, you see it's somewhere down below. You have to set it to the same location as our handle is. So I will do the same. So copy location from handle and put it to grab component. And adjust it towards the lever, like this. So it's around here. And after you're done with positioning your grab components inside their respective objects, and now make sure that both your grab components you have now have grab type set to custom. That's the essential part. And in here, I will click on my lever grab component and I will click ungrabbed, and the same I will do for undropped. So here we have two events for this. The logic I'm going to show you right now, the way lever works, I actually took it from GDXR, and this logic I didn't create myself. So he has a video on YouTube how to do it. So now when I grab the lever, that's actually when our car should move. Therefore, we will get our vehicle movement component and we'll set handbrake input. That means that we're applying handbrake or no, and it should be set to false. because when we grab our handle, we don't want to have our handbrake like active right now, so we're actually moving the car. Therefore, we're setting it to false. Afterwards, I will set timer by event, and I will let it trigger every 0.01 second, and I'll make sure it's looping. So then we create a custom event. So we drag from here, create custom event, and let's call it move handle. In here, I'm going to get my handle, and I'm going to get my motion controller from here. So let's go ahead and promote it to a variable for now, and let's call it handle motion controller, like this. And here we're going to use it. So I will get world location of my handle, and I will get its world rotation as well. So get world rotation. And I will get my world location of my motion controller. So first of all, I'll do that. I'll get my handle MC, get world location. Just to make this logic work, go to your viewport and make sure everything is pointing towards x-axis. So as well as car, because if your car doesn't look on the x-axis and you have exported the model wrong, the lever will behave in the wrong way. So here we find look at rotation, connect this pin to here. And here we are getting forward vector. Afterwards, from here we get rotation x vector, and we make a dot product of the vectors here. Afterwards, we multiply it by a number, and actually this number is responsible for the speed our lever is going towards our hand. So if you put a really big value here, it will be almost immediate. And we take our handle, we get relative rotation, and we just add this value to our white pitch. And now we need to clamp the movement because we don't want our handle go in the car. So values I found are working good is from minus 70 degrees, so around here, to 70, around here. So that's what I'm going to do. I'm going to clamp float from minus 70 to 70. Like this. And finally, I'm going to drag from my handle, set relative rotation, and split the structure pin and connect this return value to Y, like this. So now we need to work with our speed. And you remember, when we have our vehicle movement component, and we're working with its brake input and with its throttle input, we have value from 0 to 1. We don't have minus 1. So what I would suggest doing is that from here, we'll map wrench clamped. So basically, we'll now clamp this value. So we'll clamp the value from minus 70 to 70. And as output, we're going to get a value from 1 to minus 1. And we're going to check if this result is greater than equal and 0. And if it is, it means that we are accelerating. Therefore, I will get my vehicle movement component and I will set throttle input from true to this value right here. Like this. And I will have to make sure to set brake input to 0 since we are not braking. And on false, we are doing almost the same. And when this is false, it means we are braking. So we need to set brake input to the negated value from here because we're getting values from 0 to minus 1. So we need to multiply this by minus 1 to convert it from 0 to 1 and set it to brake and connect it on false. And as well, we need to set our throttle input to 0, like this. And here on dropped, what we'll do, we'll pause timer by function name and make sure you will put this function name here. So move handle, copy this value, and put it here. Like this. So hit compile and save. And also guys, before we actually jump into the game, make sure that here you multiply your forward vector by minus 1. So multiply by float by minus 1 and connect it to the dot product right here. So now if I jump to the game, I can get inside the car. And once I push the handle forward, my car accelerates. And as you can see, I start moving. Now, once I push it back, my car goes back. And once I release it, it stays in the same place. That's what I don't want to have. I want it to come back to its initial position. And also, I want my car to stop when I release the handle and turn it to initial position. Because now, as you can see, I release the handle and my car starts moving there. And it actually goes without me. So that's what we need to fix right now. So to address this, I will go on my undropped here. So, and once we release the handle, we want our both throttle and both brake input to become 0. And we want our handbrake to be applied. So I'll go ahead and set throttle input to 0. So afterwards, I do the same with brake, set brake input to 0. And then I copied this node from here, set handbrake input. Now I set it to true because now we apply it once we release it. And afterwards, I want to make my lever come back to its initial position to rotation 0 on the y-axis. So I'm going to set another timer by event, so like this. So I will have 0.01 seconds and make sure you have looping true. I create another custom event and I will call it return, handle, and break, like this. So in here, I will just get handle, I'll get relative rotation, make sure you split the structure pin. From here, I'll get my y pitch value, I will f interp to constant, like this. So from current, and any value we have right now, to 0, our delta time, we are just getting world delta seconds, and interp speed 4 will work great. Afterwards, I'll just go ahead and set relative rotation, and I will just plug this return value to y pitch value of our handle's rotation. Afterwards, we need some condition to check if the lever has come back to its initial position. So that's why I need to check if this interpolated value nearly equals to 0. With error tolerance, I can say it's maybe 0.1 will be enough. And in case it's true, it means it came back to its initial position. We're just going to pass timer by function name, and we're going to have this function name here. Pay attention. The same function name we have here, we'll put here. And now, really crucial step, because we can release the handle, it will start coming back, but if we decide to grab it before it comes back, we need to stop the movement, right? So I will go back to my ungrabbed lever, and here, now I will pause timer by function name, and now the function name will be function name from here, from return handle and break. And I will put the name here. So now, if we jump to the game, we must see that once we release the handle, it comes back to its initial position, and moreover, it stops our vehicle. So now, once I'm here, I can get inside my vehicle, I can start accelerating, and once I release it, I stop, and handle rotates back to its initial position. But it seems like it's taking it too long to do this. We can go ahead and change our interpolation speed to maybe 20. So maybe I'll put it to even 100, like this. So now again, we can go back, full speed, then we release the handle, and our handle comes back, and our car stopped. So let's do it again. We increase the speed, release the handle, and as you can see, we have stopped. Now all we have to do is to make our steering wheel. So let's gonna go ahead and do this. Before this, I will comment everything out. We have pretty decent amount of code so far. So I will call it speed lever, like this. Make comment, and here I will move all of the code to the top, and this piece of code I will call sitting in the car, also to black, and make comment. So you had everything look beautiful. Now with the steering wheel, we have to add another static mesh, and I will call it steering wheel, and let's actually assign the mesh to our wheel that you have separated, and I will have the following location, and I will rotate it 20 degrees on the y-axis, or sorry, minus 20. So it looked like I have a wheel. So it looked like I had a steering wheel right here. And afterwards, it's essential step, make sure that your collision preset is also custom, and object type is physics body. Otherwise, grab component will give you really bad results. And afterwards, I'll add a grab component, and I'll call it steering grab component, like this, and make sure that your grab component is actually in the center of the wheel or just next to the wheel. Otherwise, you will grab some other things you don't want to grab. And make sure its grab type is set to custom. Otherwise, you will have unexpected results. Go to our steering wheel in case you haven't set up the collision. So now I don't have collision, and if you have collision, you can go ahead and remove collision here. I will add a simply box collision. I will make it a little bit smaller, and I will put it on the tip of my steering wheel, on the rim, right here. So that's the area I'm able to grab. So let's go to our event graph, and let's click on our steering grab component, add ungrabbed, and add undropped. So ungrabbed, we're going to promote motion controller to a variable. Let's call it steering motion controller. And afterwards, we want the steering wheel to follow our hands. So set timer by event. It will repeat every 0.01 second, and looping is true. And from here, we create a custom event, and we'll call it rotate wheel, like this. So afterwards, we can go ahead and copy this code from here and paste it right here. So now we have to change some variables. Instead of handle, now we have our steering wheel, and instead of our handle motion controller, we'll have our steering motion controller. Now we don't need to multiply by -1. And also we need to normalize our dot product. So normalize and connect this to here. And our multiplication value will be 50. Because now we want our steering wheel to almost immediately follow our hands. So the multiplication value here should be big. Afterwards, we get our steering wheel and we add local offset connected to here. And now pay attention because it depends on how you position your steering wheel. So in my case, it's rotating around X local axis. So you will switch to this icon. In your case, it should be doing the same too. So I will connect this pin to X axis. And afterwards, all I have to do is to get relative rotation and get the X pin from here. And I'm going to get my vehicle movement component and set steering input. And the value here, we're going to map range climbed. So in range A and range B, I want my wheel to rotate -90 at minimum and +90 at maximum. So I will go from -90 to 90. And the value in return I'll get from -1 to 1. And this I will connect to steering input. And after we drop the wheel, we release it. We'll pause timer by function name. Function name will be rotate wheel. And it's a good practice to null out the variables we don't need. Let's comment it out and call it steering. Oh, and here, sorry, instead of add local offset, we need to add local rotation. That's essential because I messed up. And connect it back. So to the x-axis and like this. And also what I forgot to do is that instead of get forward vector, use get right vector. That's also an essential part because now we're referring to the right vector. So now let's jump. You'll see that we can enter the car. Now we can take everything we need and now we can actually rotate. So holy crap. And I just to turn it on the side. That's because I haven't played with the car settings and its center of mass. You can play with it, increase the mass of the car. I will just go slowly and I'll show you. So as you can see, my car can rotate now. I can go right, I can go left. And as you can see, everything works perfect. And once you release, I can just stop. So yeah, guys, thank you for watching. I'll see you in the next one.